My name is Siti Khadijah Shamsul Dahari with metric number CF220027, and I'm going to explain about introduction. The settlement of a soil is when a building is built on newly developed ground by filling in the soil. The foundation in such soil tends to settle more over time because it takes a while for those soil to compact and settle enough to withstand the loads from the building foundation. Next is objective, which is to develop basic knowledge and understanding to analyze the soil properties and the problem based on learning after the class session and self-references, to gain skill in applying soil characteristics, geotechnic equation, and analyzing soil properties, to get the capability to make logical explanation on how the problems happen based on soil analysis inside the investigation reports. Next is the data of location, which is at Masjid Jamik Pekan.
Next is data of location. First is site investigation. The field investigation work is at Masjid Jamik Pekanas Johor was carried out from 27 July 2010 until 3 August 2010. The investigation works carried the result 3 numbers of boreholes by using the multi-speed rotary wash boring machine, and the result was collected. Next, the standard penetration test was also carried out in all types of soil, in which only soft soil and soft clay cannot be tested. The tests were carried out at 1 meter interval for the first 6 meter, and after that 1.5 meter interval thereafter, or in the change of its strata. For the value of the penetration, it was suggested to be equal with the British standard, where the number of row counts for each 75 mm penetration of the sampling tube.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wanuriliana binti Wan Muhammad Dagang with the metric number of CF220112. We'll be presenting to you about our group project, attribute limits. For quick explanation, the attribute limits refers to the liquid limit and plastic limit of soil. These two limits are used internationally for soil identification, classification, and strength correlations. When clay minerals are present in the fine-grained soil, the soil can be remolded in the presence of some moisture without crumbling. This cohesiveness is caused by the absorbed water surrounding the clay particles. At a very low moisture content, soil behaves more like a solid. At a very high moisture content, the soil and water may flow like a liquid. Hence, on arbitrary basis, depending on the moisture content, the behavior of soil can be divided into the 4 basic states: solid, semi-solid, plastic, and liquid. From all of the tables and graphs of liquid limit LL, plastic limit PL, and plasticity index PI above, we can see that all of the test results came out differently. The values of these limits are used in a number of ways. There is also a close relationship between the limits and the properties of soil, such as compressibility, permeability, and strength. From this data, we can conclude that the liquid limits for the soil is higher than the plastic limits. From that, we can see that the type of soil is seed sand soil based on the geotechnic notes. Like peat, seed is another poor soil option for building a foundation due to its prolonged ability to retain water. This quality can cause slip to shift and expand, which does not provide the building any support and puts it under repeated long-term stress. This can cause structural damage or failure.
Next, I would like to explain about particle size distribution, which is on the left hand side we have particle size distribution, and the right hand side we have the borehole and the percentage of the clay, silt, sand, and gravel. So as you can see at the data, we have the silt percentage is higher than the sand and gravel. And for the next sample, which is also the same, the percentage of silt is more higher than the sand and gravel. And for this one, for this sample, which is D25, D36, and so on, the percentage of silt is 37, and the percentage of sand is 47 and gravel is 16, which is the sand is more higher than the silt. So from the as I can conclude in this particle size distribution, the average of the particle size distribution, which is in the terms of silt percentage, are higher than sand and gravel, and sand is came after the silt, and next is the lowest is the gravel.
Hi, my name is Ahmad Dene bin Nurain, and I will talk about shear strength of the case study in SI report that they already made. And the shear strength meaning is of soil is indicative of its resistance to erosion. And from the SI report, we find is the laboratory test is using vane shear test at the field used to determine the undrained shear strength of soil, especially soft clay. These tests can be done in laboratory or in the field directly on the ground. Vane shear tests give accurate result for soil of floor shear strength less than 0.3 kg per centimeter square. And here is the result that we shown in the table is about the more circle graph, which is consists of shear strength and normal stress. And the table is about more circle, and we need to find cohesion and angle of degree, so we can make sure which level the cohesion which is. And the cohesion is alternative called the cohesive strength is typical measured on the basis of more column theory and to identify the type of soil. Then the angle of shearing is angle of shear resistance is known as component of the shear strength of the soil, which is basically frictional material and composed of individual particles.
So next is permeability. Soil permeability is known as hydraulic conductivity, where it measures the rate of the water flow through the soil properties. Flow of water in soil takes place through void spaces which are interconnected. Thus, the velocity of flow depends on the pore size. One of important soil permeability is how the permeability influences the rate of settlement of a saturated soil under load. In this case study, the coefficient of permeability can be measured to get the velocity in meters or centimeters per second of water through the soils. So this is the table of borehole 1 and borehole 2 of how the coefficient permeability can be kept. For borehole 3, we can classify to UD1 and UD2. For UD1, we can see the highest permeability is at 0.0352, and the coefficient of compressibility is 3.468, and the coefficient of conciliation is 1.03. Meanwhile, the lower permeability is at 0.0056, and the coefficient of compressibility is at 0.814, and coefficient of conciliation is 0.70. Meanwhile, for the UD2, we can see that the highest permeability is at 0.0367, when the coefficient of compressibility is 0.888, and coefficient of consolidation is 4.1. Meanwhile, of the lower permeability is at 0.0088, when its coefficient of compressibility is at 0.291, and the coefficient of consolidation is at 3.09.
Compressibility in when a mass of soil is subject to compressive force, its volume decreases resulting in settlement. The property of soil that result in a reduction in volume when subjected to pressure is called soil compressibility. And this is the result that we found in borehole 1, which is borehole 1, 2 and 3, and when the result is failure type is intermediate.
It's a correlation of physical properties with mechanical properties in liquid limit and shear strength. When the water content is increases, the shear strength will decreases. So therefore, in this report, the average undrained shear test strength of the soil sample is 13.4 kilonewton meter square. It can be considered that the soil sample have the highest shear strength because the undrained shear strength of the soil at liquid limit is around 1.7 kilonewton meters square. According to the curve, the liquid limit of the soil decreases. As I mentioned before, as the water content or liquid limit decreases, the shear strength of the soil will increase, and this correlation shows that it's indeed silty sand due to the decrease of water content.
In this study case, according to the site investigation report, the average permeability results of the soil sample is 0.02 cm per second. It can be considered that the soil sample's permeability is low because the pure clay will have a coefficient of 0.05 cm per second, while pure sand will have a coefficient of 5 cm per second. Low permeability in soil means that water moves slowly. Soils with low permeability have a lot of clay and seed. Seeds feel sticky smooth when wet as it absorbs water. Because clay has a fine texture, unlike sand, which has a coarse texture that becomes sticky and plate-like when wet, rubbing it off air pockets, and it takes a lot of longer for water to infiltrate and drain away.
It's a correlation of physical properties with mechanical properties in liquid limit and shear strength. When the water content is increases, the shear strength will decreases. So therefore, in this report, the average under shear test strength of the soil sample is 13.4 kilonewton meter square. It can be considered that the soil sample have the highest shear strength because the under shear strength of the soil at liquid limit is around 1.7 kilonewton meters square. According to the curve, the liquid limit of the soil decreases. As I mentioned before, as the water content or liquid limit decreases, the shear strength of the soil will increase, and this correlation shows that it's indeed silty sand due to the decrease of water content.
So next is correlation of percentage of clay and permeability. For the correlation between the percentage of clay and permeability is the more materials can allow the water, the permeable it is. For the permeability of a clay, it shows that clay has least permeability since it's well known as sticky and wet soil texture. Therefore, several factors can be considered to determine the permeability in clay soil. Among the factors, the most suitable correlation of percentage clay and permeability is the pressure applied to the soil sample. From the data site investigation report, the sample is most likely seed clay soil, in which can be concluded that site is need an essential foundation to prevent of any failed structure.
Based on the test, data and information that have been collected in this report, the correlation between liquid limit, shear strength, permeability, and percentage of clay shows that the soil is indeed in the state of silty sand soil, which can be concluded that the failure settlement of the soil is due to the type of soil and lack of test. Therefore, the solutions for the soil settlement for this project are the soils must be truly compacted before construction can start on them, and the foundation depth must be increased to reach the hard strata or rock beneath the field soil or pile foundations in order to stop foundation subsidence so that there are less holes or space between soil particles as a result of applied stress or change in moisture content, which cause settling. Also, for our future studies and also for engineers, we need to do more tests and analysis that could confirm if the soil is suitable or not for construction work so that the problem due to soil properties can be prevented.
And last but not least is a conclusion. The settlement failure at Masjid Jami' Pekananas, Johor was caused by lack of shear strength test because of the type of soil, which is silty sand, that we have been concluded before. This which is silty sand. Silty sand soil tends to have low bearing capacity. Therefore, the failure of soil settlement occur by analyzing the result of this study and considering these factors foundation and landscape design. The best answer for the type of foundation and type of potential improvement for a proper soil will be determined.